Okay, so let's move to the back side here. We got a few more examples. Hopefully you guys can give them a try this time. Figure out the properties based on these equations. Same ideas we did on the front side, just different versions of them, right? Okay, so the first thing we want to do, find our leading coefficient. Okay, look for the highest exponents right there. The number in front of that is a positive 1. Okay, my degree, our highest exponent is 7. My end behavior, as I go to the right, it's a positive leading coefficient, so I'm going up. As I go to the left, it's a odd degree, so I have to do the opposite. I go down to the left. Okay. Part 4. How many zeros could I have? Well, it's an odd number, so I have to have at least 1 and up to my exponent, so up to 7. Okay, and does this have a min or max? Well, we said it's odd, right? Which means it goes up and down forever and ever, so not applicable. Okay, try D if you haven't yet. Pause it if you need to. Okay, our leading coefficient would be negative 3. This is my highest exponent. Out of order, you just got to find it. Okay, my degree would be 3, the exponent. My end behavior, go to the right, negative leading coefficient, so I'm going to go down. Go to the left. Leading coefficient will be the opposite because it's odd, so it's going to be a positive. How many zeros do I have? It's an odd exponent, so 1 at least up to my exponent of 3. And does this have a min or max? No, of course not, because it's odd behavior, opposites. Okay. Hope you got the hang of those. We'll try to look at a graph this time, figure out some properties. So, we've got a polynomial here, some sort of polynomial. What can we tell by looking at this picture? Well, the leading coefficient, I know that has to be a negative. And I know that my justification is the graph goes down to the right. And that's how we justify something, explaining, our reasoning. That's our why. Okay, our domain range, right, domain. Well, it's a polynomial, right? We've said all polynomials go on forever and ever and ever, which makes sense in this graph. It's getting left and right, wider and wider. Our range, it's made up of lines, but it reaches a maximum right there. That value is 1, 2, 3, 4. So we know that this graph is always less than or equal to 4. It never passes 4. Hey, our end behavior. We're looking at a graph that's pretty easy, right? To the right, it's going down, negative infinity. To the left, also going down. I can see that. And part D, what is the least possible degree? Yeah, so our choices, we have 0 to anything, right? Now we know it's got to be an even degree because my end behaviors are the same. There's 2 things over here. It tells me it's even. So it could be 2, 4, 6, 8. The hint that we're going to get here is how many zeros we have. We've got 1, 2, 3, 4. If it's got 4 zeros, it has to be a degree of at least 4. It could be 6, I suppose, or 8, or 10, or one of those weird ones. But I'm going to guess degree of at least 4, okay, because there are 4 zeros. That's our justification. The number of zeros is your degree, at least the minimum number of your degree. Okay, last idea. We looked at graphs, we looked at equations. Let's take a look at some tables. Tables are helpful tools in helping us figure out which kind of function we have. And we can do that by looking at the differences in our y values. We call those our finite differences. Yeah, the x's don't really matter. It's all about the y's here, okay? If our first differences are the same, that is, we find all the different y's and figure out the same number over and over and over again, we'd say it's a linear function. Oh, it's always going up by 2, up by 2, up by 2, up by 2. Okay. But if they aren't the same, we try it again. We call that second differences. That would tell us that it's a quadratic function. And then we could try it again, the cubic differences, the third differences, and fourth, and so on and so on and so on. Okay, so we're looking at the y value. That's our key here. So take a look at the first one here. I'm going from negative 57 to negative 28. So I've gone up 29 units. From negative 28 to negative 11, I've gone up 17. Then I've gone up 11. I've gone up 11 again. I've gone up by 17. This is my first differences. The differences in the y's. They are not the same, right? The numbers keep changing, so it's not linear. We'll try it again. Second differences. From 29 to 17, I've gone down, so negative 12. 17 to 11, I've gone down 6. 11 to 11 haven't changed. 11 to 17, I've gone up 6. Those aren't the same, so it's not quadratic. Try it again. Third differences. From negative 12 to negative 6, I've gone up 6. From negative 6 to 0, I've gone up 6 again, and the third one I've gone up 6. So my third differences are the same, which tells me that this is a cubic function. Okay. The other nice thing about the sign of your differences is it gives you the leading coefficient. Okay, because I have 6's all the way through here, okay, my leading coefficient is positive. And I know that because I have a positive 6. And not about the number itself, it's about the value of the sign of that thing, right? Just like it has been for everything else. Okay, which means this graph probably goes up to the right. Hey, give the last one a try, see what you can do with it. Okay, first, second, third differences, whatever you need to find there. Okay, from 1 to negative 2, I've gone down 1, then down 5, then down 9, then 13, then 17. Oh, those aren't the same, not linear. Try it again. Gone down 4, I've gone down 4, oh, I've gone down 4. Hey, I've gone down 4, they're all the same. That makes this a quadratic. My second differences. And what would our leading coefficient be here? The leading would be negative. I got negative differences. Okay. And there's how we can figure out some properties from tables, graphs, and equations for some cubics, quartics, and other polynomials. And give the homework a try. Maybe try the quiz tonight and see how you can do on that stuff.